Let's first start by reviewing how to add like terms. So if we have something like 2x plus x, well, then we have 3 x's total. So I can pretend like there's an invisible 1 here and say that I have 2 plus 1 is 3 x's. So this works with more complicated expressions. If I have 3 xy's and I subtract 4 xy's, well then I have 3 minus 4, which is negative 1 xy's. And since 1 times xy is just xy, when we simplify, we don't include that 1 there, and we just write negative xy. So an expression that looks like this, if we have 2x squared y squared plus 3x squared y squareds, well, if we combine those all together, we have 5x squared y squareds. And if we're subtracting this x squared y here, well, there's nothing we can do to combine these terms and these terms because they are different. So if expressions that look like this, x squared plus 2x plus 3, and 3xy squared plus 4x squared y, there's nothing we can do to simplify these things any further. The reason is the number in front of our monomial indicates how many of that quantity we have. Like back here, we had 3xy's, and we are subtracting 4xy's. And down here, we have an xy squared and an x squared y. Since they're not the same thing, we can't just add them together and say that we have something like 7xy squared. It doesn't make sense. It doesn't work. So the rule is, when you're adding like terms, is that you can add terms if they have the same variables with the same powers. If they don't have the same variables or they don't have the same powers, like back here, the powers are different, you can't add the things together. Another important point here is that powers on variables don't change when you do addition or subtraction. So back here, when we added x squared y squared, or 2x squared y squared, with 3x squared y squared, we got 5x squared y squared. The powers didn't change. Okay, so you also covered multiplying monomials in your last homework. So to start, let's review the distributive property. So if you want to do 5 times the quantity 3 plus 4, well, that means you have 5 3's and 5 4's. So you have to do 5 times 3 and then 5 times 4 and add them together. So 15 plus 20 gives you 35. So this rule stays the same even with more complicated expressions. So let's say we want to do 2x times 3x minus 2. Well, then we got to take this 2x and multiply it by this first guy, and take this 2x and multiply it by the second guy. So 2x times 3x gives you 6x squared. 2x times a negative 2 gives you a negative 4x. So you have 6x squared minus 4x. So let's combine multiplying monomials in this fashion with some of the rules we learned last week, which I include in the video exponent rules. So let's say we have this problem and we want to simplify it. So first, we have to, our rules of order of operations say we have to do exponents first. So first we're going to have to simplify this quantity. So if I'm squaring this quantity, we learned in the last video that we have to square each term in the quantity. So we have 18 times, well, I have negative 2 squared, which gives you 4. Negative 2 times negative 2 is 4. X squared squared gives me x to the 4th. The powers multiply here. And y squared, well, that's y squared. 3 squared is 9. So I get 9 on the bottom. And now if I distribute here, well, remember I have to take this guy and multiply it by each term in this quantity and then add them together. So if I have 3x squared y squared times x squared, well, x squared times x squared is x to the 4th. So I have 3x to the 4th y squared. Then 3x squared y squared times negative x, well, that gives me negative 1 times 3 is negative 3. X squared times x is x cubed. And then I still have my y squared. And now 3x squared y squared times 1 is just 3x squared y squared. So now I do a little more simplification here. 18 divided by 9 is 2. 2 times 4 is 8. So I get 8x to the 4th y squared plus 3x to the 4th y squared minus 3x cubed y squared plus 3x squared y squared. Now I can combine these two terms together because I have the same variables with the same powers. X to the 4th y, 8x to the 4th y squared plus 3x to the 4th y squareds gives me 11x to the 4th y squareds. But now I can combine these guys. They have the same variables, but they have different powers on them. So I just have to leave those as is. So I have minus 3x cubed y squared plus 3x squared y squared. And that's about as simplified as I can make things look. Okay, now let's say we have a problem. Let's say we have to solve an equation. So we start by, so this equation looks really nasty at first. But if we do some simplification, just like we did in the other problems on both sides of the equation, it'll end up looking a lot nicer. So we start by simplifying both sides. So here I take my 4x, I multiply it by my x, and by negative 3. 4x times x is 4x squared. 4x times negative 3 gives me minus 12x. And then I have my plus 4 there. Okay, negative 2x quantity squared. So I have to square each term in here. Negative 2 squared gives me 4. X squared is x squared. All right. Now here I distribute my negative 2. So negative 2 times x gives me negative 2x. Negative 2 times 3 gives me negative 6. All right, and now I want to move terms. I want to combine terms on both sides of the equation. So I have a 4x squared and a 4x squared on both sides. So I'm going to subtract 4x squared from both sides. 4x squared minus 4x squared gives me 0x squared. So I'm left with negative 12x. Negative 12x plus 4 is equal to negative 2x minus 6. And now I can add my two x's to both sides, or I can add 2x to both sides. Negative 12x plus 2x gives me negative 10x. And then I have plus 4 is equal to negative 6. And now I can subtract 4 from both sides. And I get negative 10x is equal to negative 10. And if now I divide both sides by negative 10, I get x is equal to 1. So the nice thing about having solving an equation is you can always check if you're right. So after doing a whole bunch of work, we said x has to be 1. Well, we can check if we're right by replacing all our x's with 1s. So if we did the problem right, if we replace x with 1 on this side of the equation, we should get the same number as when we replace x with 1 on this side of the equation. So 4 times 1 minus 3 plus 4 should equal negative 2 times 1 squared minus 2 times 1 plus 3. So on the left side of the equation here, 1 minus 3 is negative 2. Negative 2 times 1 times 4 is negative 8. Plus 4 is negative 4. So we get negative 4 on the left side of the equation. On the right side, negative 2 times 1 is negative 2. Negative 2 squared is 4. So we get 4 minus 2 times 4. 4 minus 8 is negative 4. So on the left side of the equation, we got negative 4. On the right side of the equation, we also got negative 4. So our answer is correct.